Okay, this is section 5.3, and as you notice, I've got the same background here. We are dealing with rational functions, which is kind of like a fraction. It's a numerator and denominator, but it's more algebraic. Just some various little things that I found. Determine the domain. Find the location of holes. Most of them that we deal with will not have holes. A hole is when it has the same factor top and bottom. Determine the equation of the vertical asymptotes. Usually the vertical asymptotes is where the denominator equals 0, would be x equals that. So the domain and the vertical asymptotes are closely related. The horizontal asymptotes, it just depends. If the bottom is the largest power, your horizontal asymptote is the x-axis, or y equals 0. If the powers are the same, then you have a line y equals the coefficient of the numerator and the denominator, just a constant term. And if the top is the highest, you don't have any horizontal asymptotes. You might have an oblique asymptote, which we'll talk about a little bit too. And then finding your x and y intercepts. X-intercepts are where y or the function value equals 0. The y-intercepts are when x equals 0. And this is just the basic strategy for doing this. When the denominator equals 0, vertical asymptote. When the degree of the numerator is less than the degree, the x-axis, or y equals 0. If the degree is equal, you find the ratio of the leading coefficients, and it's a horizontal through the ratio is that horizontal. And if the degree is greater than the degree, if the top is greater than the degree of the bottom, then use division to rewrite the function. And then the resulting equation is what we call an oblique asymptote. Okay, so we want to analyze this function. The first thing is to be concerned with your domain. What makes the denominator equal 0? Well, we set the denominator equal to 0, set the individual factors equal to 0, and solve. So either 0 or negative 17 will make the denominator 0. Those are the two things that you must leave out of the domain. Now, directly related to that is, what is the equation of the vertical asymptotes? These occur where the denominator equals 0. So it's simply x equals negative 17 and x equals 0. These are just vertical lines that go through where the bottom would have been 0. What is the equation of the horizontal or the oblique? Well, the top power is 1. The bottom power, if you multiply this together, is x squared plus 17x. So the larger power is on the bottom. So the bottom gets larger faster, and your horizontal asymptote would be y is equal to 0, or it's the x-axis. Okay? Now, you'll never cross a vertical axis, but you can cross a horizontal axis close in. Because see, this is graph down here. You actually are crossing. Where are you crossing at? You're crossing at negative 14, because that is the 0 or the x-intercept. But otherwise, it's not. The horizontal directs it more towards the ends as opposed to in the middle. Which graph shown below is the correct graph? And of course, this is it. You look for the asymptotes where they're supposed to be and double check your intercepts and zeros. So you've got you would have 1 0 at negative 14. You've got an asymptote at negative 17, an asymptote at 0. And if you put it in your graphing calculator, you can kind of verify that. See, that's the 0 at negative 14. So this is it. I put in lines to show you the asymptotes also. Those are your 3 asymptotes, and they're lines now. All right, I hope you understand.